All right. What's up, guys? Welcome back to episode 3 of How to LeetCode beginner series. Today we're going to be solving what I said we were going to solve in the last episode. 206, reverse linked list. Here we go. This is going to be a two-pointer strat problem. We're going to use this strategy to. Our goal is to basically reverse the linked list and return the new head. We got a little bit of preface. Um, Simple enough. We have a linked list 1, 2, 3, 4, 5. In this example, 5, 4, 3, 2, 1. Simple enough, right? This is one of those things where like we want to understand linked lists, bro. As a comp sci student, we don't want to be cooked. So during the interview, you want to be able to do this, right? You want to be able to solve this easy problem, you know. I Funny enough, I know like when I was first learning this stuff like 4 years ago, it did take like the best way for me to sort of understand these problems is always to draw a picture, draw these things out. It just helps you being able to visualize it will just make it 10 times easier. Trust me on this one. And we could jump right into it. We could open Paint, and let's say we have a linked list like this. Expand this over here. We're going to be playing around with the .next, the references, right? We're actually going to have a pointer that points to none, right? We're going to have a current, you could call it a previous pointer, but previous is just going to be initialized to none in this case. And the current pointer is going to equal to the head. And we're also going to introduce this new, you're going to see this a lot. You're going to see dummy nodes a lot. You're going to see temporary nodes a lot. And bear with me, I have my retainers in, so I'm going to have a little bit of a lisp. Sorry, bear with me, guys. Temp, we could just set it to none. And we're going to see why temp is going to be useful, okay? So how are we going to get this to 5, 4, 3, 2, 1, right? We have to understand something about a linked list. So if we wanted to delete this node, this value, right? How would we delete that? We would just move this value, this node's .next to over here, right? Pointing to 3, effectively getting rid of this because that's just going to be lost to memory. But in this case, we want to use temp to store that value so that we can have it and then flip this value. You understand? And we're going to be doing that throughout the entire list. So the strategy here is to have prev not over there. We're going to have prev over here first. And then we're going to start the head obviously at the start of the linked list. And then we're going to have a temporary variable that we're going to use to hold the connection so that we still have a reference to that while we break this connection. Because in order to reverse it, you'll see how we're going to break this connection and sort of flip it. And we'll visualize that. And there has got to be a way to like delete this better, but bear with me. Okay, so first thing we're gonna do, current, right? We want to save this .next. We want to save this .next and then use it for later. And we're just going to say, hey, our temporary variable is going to be the current .next. So in this first iteration, it's going to save to this pointer, right? Perfect. Okay, so we have that. Now we are going to take our current .next, and then we're gonna effectively break this. Well, we don't want this. We don't want this anymore. We want to turn this and actually reverse it and have it point to none. And we could set that by, hey, look at our pointer here is actually in the perfect spot to do that. So we could just set current.next to prev or to p. After that, then we could effectively, we want to move our pointers. And this is cool because we can just take our prev, and then we can move it, shift it to where our current pointer currently is, which is at 1. So now we're at 1. Our current is going to be equal to our previous pointer. This is going to be shifted here. So by 1. Boom, easy, right? And now effectively we're in a good spot, so we can move our current. And see, this is why we wanted to save our temp, because when we get rid of this connection, we're losing this entire linked list, and we don't want to lose that, because how are we going to reverse how are you going to reverse the linked list if there's no linked list to reverse? So we're saving this section so we can reverse the end of the linked list, and then previous at the end will actually be in the perfect spot, because this will move down like this by 1, and then at the last iteration it will be at the perfect spot. So prev will actually very nicely land at the head, so we can just return our value, which is what the problem statement is asking for. So our current pointer now is going to be set to the temp variable. So now we have a copy, right? And this is perfect now. We just change this, and then it'll keep going at the end, and we'll reverse it like this. And prev will end up here. And our current obviously will also go all the way here, but current at that point, it doesn't really matter. That might not have been the best explanation. However, we'll see why this works in the code in when we actually start coding it. Sorry. Okay, yeah. So this is a good spot. Now we can see the main idea again that I want to take away with you guys is that you're going to be seeing a lot of this use a temp variable to hold the memory reference, so that we don't lose this while we're trying to do something over here. That's the main idea of this problem. So yeah. Okay, and we're back. Main idea again is we're going to be using that temp variable to hold the reference, so that we can slowly reverse the linked list bit by bit while keeping our connection to the rest of the list. So usually in the previous 2 problems we solved in the series, we only had to initialize a left and right pointer, right? But in this case, we're just going to have temp hold the memref to the rest of the list. And then we can initialize our current pointer to the head, and then we can initialize our previous pointer to none as well, pointed to. And again, I've mentioned this earlier, none is just null. Null is nothing in Java, or null is nothing in Java. They're the same thing. We want to do this while there is a node, right? Because if we hit null, then we know that we reverse the full linked list, and there's no tricks here. There's no little edge cases you have to worry about. Yeah, this example 2, same thing, 1, 2, just 2, 1. While current, right? First, what did we say? It's literally the code, boom, from here. This is literally our algorithm. This is literally the entire algorithm. So if I'm doing this correctly, if I'm doing this correctly, our temp is going to be equal to current.next, right? We're going to save a copy for that for later. Then we're going to take current.next, and then we're going to set it equal to the prev, because prev, again, this is going to point to none, point to nothing. And then after that, we can increment prev and slide that over by 1, which is where current is. After that, we could take yeah, we could take that, and then what did we save earlier? The temp var to the rest of the list we're reversing. And the time complexity of this, let me just finish the code, not prev, temp. And then, like I said, the prev pointer will actually be in the perfect place for us to just return. And we're going to talk about the time complexity. This is going to be O of n, where n is going to be the length of the linked list. And again, this is just saying, hey, we're using that pointer to save a copy, reversing the links. After we reverse the links, we can point them to the right direction because we have saved that copy. Okay. And now I sound like a broken record, but you guys get the gist. We can go ahead now and return our prev pointer. And that's basically it. Let me run it, see if it works. And boom. Submit. And yeah, this is how you reverse a linked list in Python. Again, you might have to, go over this, draw it out just to understand. You can go back to the section of the video where it said that previously. And then yeah, you can I'm pretty sure you can put in your own test cases on. Yeah, you can. You can put in your own cases, like obviously this is the base case, empty case. But again, a really good problem to understand the .next. Yeah, we're eventually gonna get to doubly linked lists where you can go backwards, instead of just having a reference to .next to here going this way, you can actually go backwards. It already has a prev, right? There will be problems going over that. And yeah, I'm Jeff. I'm your host. I'll see you guys in the next one. Study hard and good luck on next semester of school if you're still in school. Good luck on work. Good luck on whatever you're trying to do. Peace. Peace.